Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great tool for you to practice your class 12 question papers as well as your entrance exam question papers. Students, you must download our app. The link is available in the description box. Today we'll be solving CBSE class 12 Mathematics 2020 Delhi Set 1 paper. Near about 40 questions are being asked in this in this paper. And I hope already you are well prepared with your exam, and this video will help you prepare even better. Let's start with this question number 1 from this paper. All the best. Here we go. Question number 1. Now, this is from 1 to 10. You have the multiple MCQ, multiple choice questions. You have to select the correct option. Now, first question is from the matrix. A is a square matrix of 3 by 3 order such that A into adjoint of A is equal to 10i. Then, what is the determinant of adjoint A equal to? Okay, so see, in this question, let's consider one thing. You know one thing that A into adjoint of A is equal to determinant of A into the identity matrix. This is the identity. This is one of the matrices identity. Now, thus comparing it with the given equation, this A into adjoint of A is equal to 10 of I, which means determinant of A is equal to 10. Right? If A's determinant is equal to 10, then you have one more formula. Determinant of adjoint of A is equal to determinant of A raised to power n minus 1, where n is the order of the matrix. N is order of the matrix. That means here in this question, you are given n is equal to 2. That means adjoint of A determinant is equal to A determinant raised to power 3 minus 2. Or this is equal to 100. So you have option C as your correct answer. Hope you understood that. Let's move to the next question. Question number 2. If A is a 3 by 3 matrix such that determinant of A is equal to 8, what is the value of determinant of 3A equal to? This is actually very easy question. You are given this, that's this. Determinant of A is equal to 8. Let's talk about a general formula. Determinant of K into A is given by K raised to power n into the determinant of A, where n is the order of the matrix. N is order of the matrix. That means, see here, determinant of A is this and K is this. So comparing it with this, 3A, this is equal to 3 raised to power n, which is a 3 by 3 matrix. So 3 raised to power 3 into determinant of A. That is 27 into determinant of A is 28, which is 216. So the answer to the question is option D. Hope you got that. Let's move to the next question, number 3. If y is equal to A into e raised to power 5x plus b into e raised to power minus 5x, then what is the second derivative of y with respect to x? So you are given here, let's write down y is equal to A into e raised to power x, b into e raised to power minus x, dy by dx is equal to 5 into A into e raised to power x minus 5 into b into e raised to power minus 5x. Fine. So I'll take the 5 outside. Right. Let's differentiate again with respect to x. Differentiating again with respect to x, you will have here d square y upon dx square is equal to 5 will be here. This will be 5 into e raised to a into e raised to power 5x minus 5 b into e raised to power minus 5x. So this is equal to, I'll take the 5 again outside. This is equal to 25 a into e raised to power 5x plus b into e raised to power minus 5x. And you know, this was, what was this equal to? This was equal to y. See in the question, from 1. So from 1, d square y upon dx square is equal to 25y. So that means your option A is the correct answer. Hope you understood that. Next question number 4. You have to find the integral of x square ex whole raised to power 3. No, this is, wait. This sum needs some correction. This sum is integral of, let's say this is equal to I, integral of x square e raised to power x raised to power cube. Okay. So this is the actual question, right? Now let's solve it. I'll put x cube is equal to t. So derivative will give me 3x squared dx is equal to dt. So this I integral will become 1 by 3 e raised to power t dt, correct? Which will be equal to, what is that? This is equal to 1 by 3 e raised to power t plus the constant c. What was e raised to power 3? This was x cube plus c. So this is 1 by 3 e raised to power x cube, right? That makes your option A to be the answer. Hope you understood that. Next is question number 5. Question number 5, if I, j, k are unit vectors along 3 mutually perpendicular directions, then which of the following is true? You are given I, j, k are vectors mutually perpendicular to each other. If these vectors are perpendicular to each other, that means their dot product is equal to 0. Why is that? Dot product of perpendicular vectors is equal to 0 because it contains the sign of, cos of angle between them, right? And cos of 90 is equal to 0. So that means they are equal to 0. That means I into j is equal to j into k is equal to k dot I vector, and all of them are equal to 0. And also one thing, if they are like they are perpendicular to each other, the cross product of them, this is the dot product of all the three, like within each other mutually, their dot product is equal to 0. If I talk about the cross product, I cross j is equal to k vector, I dot k is equal to j vector, or k dot I. K vector dot I vector is equal to j vector. Similarly, j vector into k vector is equal to I vector. So this is wrong. Dot product things, I into k. Yes, this is right. This is right. Option C is correct. I into j is equal to 1. This is incorrect. I into k is equal to 0. This is also incorrect. And we have all the correct ones. Option C is the answer. Hope you got that. Next is question number 5. ABCD is a rhombus whose diagonals intersect at E. Let's make that rhombus first. So this is the rhombus A, B, C, and D. The diagonals intersect at E. Now EA, which is this vector, plus EB, plus EC, plus ED. Okay. These are the 4 vectors, fine. Then EA plus EB plus EC plus ED equals to what? Now, you are given that this this rhombus has a diagonals that intersect at E. Since in the rhombus, diagonals bisect each other. Rhombus, diagonals bisect each other. Therefore, see over here, the magnitude of EA vector is equal to the magnitude of EC vector. Also, the magnitude of EB vector is equal to the magnitude of ED vector. Correct. But since they are in the opposite direction, so if I talk about the vectors, then EA vectors is equal to minus EC vector. EB vector is equal to minus of ED vector. Why? Because they are in the opposite direction. They are in opposite direction. Correct. So therefore, let's add them. You have EA plus EC is equal to 0 and EB plus ED vector is equal to 0. Let's say this is adding 1 and 2 and adding both of them. Adding both of them, you have EA plus EB, EC and ED vector is equal to 0. And this is, okay, not, this is was not something to prove. This is what you had to find out. If this is equal to 0, option A is the correct answer. Hope you understood that. Let's move to the next question, number 7. So the lines x minus 2 upon 1, y minus 3 upon 1, 4 minus z upon k, and this line, they are mutually perpendicular. Then you have to find out the value of k. First line is given by this. Four minus z upon k. Now the direction ratios over here of first line 1, 1 and minus k. See over here, what I have to do is I can write it as, because I want to have the non-negative coefficient of z. So this will be written as like this. Okay. So these are the direction ratios for the first line. And the second line is given by x minus 1 upon k, y minus 4 upon 2, z minus 5 upon minus 2. So here the direction ratios of the second line are given by k, 2 and minus 2. Now we know that two lines, if they are perpendicular to each other, if the dot product of the direction ratios is equal to 0. Two lines are perpendicular if we discussed in the last question itself. So two lines are perpendicular if dot product of their direction ratios is equal to 0. So therefore 1 into k plus 1 into 2 plus minus k into minus 2 is equal to 0, k plus 2 plus 2, k is equal to 0, or k is equal to minus 2 by 3. This is the answer to the question, minus 2 by 3, option A. Hope you got that. Let's move to the next question. Question number 8, the graph of the inequality 2x plus 3y is greater than 6 is half the plane that contains the origin, half the plane that neither contains the origin, not the point on this line, whole xy plane excluding the points on this line, or entire xy plane. Let's consider the inequality which is given, that's 2x plus 3y is greater than 6. This can be written as 3y is greater than 6 minus 2x, or y is greater than 6x, 6 minus 2x upon 3. Now, let's consider y is equal to 6 minus 2x upon 3 and plot the graph. So, for plotting the graph, of course, we need the coordinates. So, these, if x and y, if I'm putting x is equal to 0, then y comes out to be 2. And if I'm putting y is equal to 0, x comes out to be 3. So let's plot the graph over here for the same. Now this looks something like, so here's the coordinate x is 0. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So when x is equal to 0, y is equal to 2. This is the first point. And when y is equal to 0, then x is equal to 3. So this is the point. Okay. Yeah. So I'll make the dotted line over here. Why? Because we don't have the equality sign, right? We have the inequality sign. So that is why we have used the dashed line. Dashed line represents inequality. Okay. Now, because y is greater than this value, actually y is greater than this value. Therefore, I will shade the upper part. So that means y will contain all of this region. Okay. So I hope you're clear with this. Now I have shaded the part because this arrow part, this is representing because y is greater than 6 minus 2x upon 3. So thus this graph which is given to you, thus 2x plus 3y greater than 6. Only see half the plane that contains the origin? No. Half the plane that neither contains the origin nor the points. Yes, this is true. It's because this plane, this much plane, this is not containing the origin as well as this was the dotted line. Remember, this was your dotted line and this does not contain the point on the line, this also. So we got our answer. Option B is the correct one. If you look at the last one, whole XOY plane excluding these points, no, not whole, because we are not including this region. An entire XOY plane, no, this is even not true, right? That means only option B is the correct answer to the question. Hope you understood that. Next is question number 9. A card is picked at random from a pack of 52 playing cards. Given that the picked card is a queen, the probability that this card be a card of spade is. So I'll say let A be the event that picked card is queen and event B represents card of spade is picked, right? So if I talk about the probability of A event to happen, queen, how many queens are there? 4. And how many total cards are there? 52. That makes it 1 upon 13. And similarly, the probability of event B to happen is equal to 13 because there are 13 spade cards out of 52. So that is equal to 1 by 4. Now, the probability you want both the events to happen. So that means probability A intersection B. This is given by, see, there is only one queen. If I keep it like this only, if there's only one queen of spade. So that is 1 out of 52 cards, right? Because only one queen of spade is available. Okay, so what you need to find out in the question is probability B upon A, which is given by probability A intersection B divided by the probability of A, which is equal to 1 upon 52, and probability of A was equal to 4 upon 52. I'm taking this value. That will give me 1 by 4. That means you have option C to be the correct answer. Hope you understood that. Let's move to the next question, number 10. A die is thrown once. Let A be the event that the number obtained is greater than 3. B be the event the number obtained is less than 5. What is the value of A union B? So dice is thrown. There are 6 possible values. Outcome, sample space is this. Now A be the event that the number is greater than 3. So probability of A is, what is the A event actually? A event represents the number 4, 5, 6. So probability of A is equal to 3 upon 6, or this is equal to 1 by 2. Now, what does the B event represent? It is numbered less than 5. So 1, 2, 3, 4 numbers are less than 5. So probability of event B to happen is equal to 4 upon 6. That is equal to 2 upon 3. Okay. Now, what is the P A union B? For that, first of all, let's find out P A intersection B. That the probability number is greater than 3 and less than 5. There is only one such number, and that is 4. So this is equal to 1 upon 6. Okay. You have to find out probability A union B. This is equal to probability A plus probability B minus probability A intersection B. This is equal to 3 by 6 plus 4 by 6 minus 1 by 6, which will be 7 minus 1 upon 6. That will be 1. So you got your answer. Option D is the correct answer. Hope you understood that. Let's move to the next question. Question number 11. Now you have to fill in the blanks for question number 11 to 15. It says the very first one, question number 11 says the relation in a set A is called dash relation if each element of A is related to itself. Now the answer to this question is reflexive. How is that? Let's say A is a set which is containing two elements, 1 and 2. So reflexive relation will be reflexive relation will be 1, 1 and 2, 2. That's it. So answer to this question is reflexive. Hope you understood that. Next is question number 12. If A plus B is given by this matrix and A minus 2B is given by this matrix, then what is the A matrix equal to? Fine. We are given A plus 2B is this 1, 0, 1, 1. Let's say this is 1. And A minus 2B is equal to minus 1, 1, 0, minus 1. Let's say this is equal to 2. So A minus 2 into 1, 0, 1, 1. See, I'm doing what over here? Question number 12, if A plus B is equal to 1, 0, 1, 1 matrix and A minus 2B is equal to this matrix, then what is the value of A? Fine, I'll start from here. A plus B is equal to 1, 0, 1, 1, or B matrix is equal to 1, 0, 1, 1 minus A matrix. Let's fill in this given matrix. So from here you have A minus 2B is equal to minus 1, 1, 0, minus 1, or A minus 2 into, okay, so A minus 2 into what is B equal to? B was equal to this 1, 0, 1, 1 minus A is equal to minus 1, 1, 0, minus 1. Hope you understood till here. So this is equal to A minus, this will be 2, 0, 2, 2 plus 2A is equal to minus 1, 1, 0, minus 1, or 3A is equal to minus 1, 1, 0, minus 1 plus 2, 0, 2, 2. And this is equal to 1, 1, 2, and 1. Okay, that's equal to 3A. And what will be the value of A? It will be 1 by 3, 1, 1, 2, 1. Or this is equal to 1 by 3, 1 by 3, 2 by 3, 1 by 3. Okay, so this is the answer to the question. Let's check with the options. You, okay, don't have any option. Naturally, you have to fill in the blank. So this is the answer to the question. Hope you understood that. Let's move to the next question, number 13. The least value of the function f(x) is equal to ax plus b upon x when a and b and x are greater than 0 is. So you are given fx is equal to ax plus b upon x. Let's find out the derivative of f. Because we have to talk about the least value, I have to find out the derivative of this function. This is given by a minus b upon x squared. Now, for maximum or minimum value, this has to be 0. Maximum or minimum or maximum value, this is supposed to be 0, or a minus b upon x squared is equal to 0. Ax square minus b is equal to 0, or ax square is equal to b. Hope you're clear till here. Now here, from here you can say x is equal to root of b upon a. Correct? Right. So let's talk about the second derivative. You already had the fx, f dash x was equal to, it was equal to a minus b upon x square. F dash x was a minus b upon x squared. So the second derivative of this function will be equal to 0 plus 2b upon x cube. And what is the value of x from here? And fill. So this is equal to 0 plus 2b upon root of b upon a whole cube. Right? Now, this is definitely going to be greater than 0 because a and b already it's told that they are greater than 0. It's told in the question that a and b are greater than 0. So definitely this value will also be greater than 0. If this is greater than 0, therefore fx is minimum at x is equal to root of b by a. And what is the least value of fx? What was the function fx? It was ax plus b upon x. I think this was the one, ax plus b upon x. Yes. So at x is equal to root of b by a, this value is equal to a into root of b by a plus b upon root of b upon a. That is equal to, here you can say this will be root a into root b plus b into root a upon root b, which will be equal to root a into root b plus root a into root b, or that is equal to twice of ab under the root. So this is the answer to the question. The least value of this function is twice root of a minus b. Hope you got that. Next is question number 14. The integrating factor of the differential equation, this is, or the degree of the differential equation, this is. You're given a choice between these two questions, and let's start with the first question, A part. The integrating factor of the differential equation dx into dy by dx plus 2y is equal to x square is given by. Here you can write down dx by dy by dx plus 2y upon x is equal to x. Here p is equal to 2 upon x and q is equal to x. You know this dy by dx plus p of y is equal to q of x. Okay. So, not the p of y, wait, it is p of x into y is equal to q of x. Okay, so here you have the value of p as 2 by x and q as x. So the integrating factor is equal to e raised to power integral of p into dx, which is equal to e raised to power integral of 2 upon x into dx. This will be equal to e raised to power 2 log x. This is equal to e raised to power log x square or x square. So this is the answer to the first part. The integrating factor of the differential equation, this is equal to x square only. Let's go with the second part. The degree of the differential equation 1 plus dy by dx whole square is equal to x is. So this is the B part. 1 plus dy by dx whole square is equal to x. So you have been asked about the degree. Degree of this will be the highest power of the differential equation, which is 2, correct? So that means you have the degree of differential equation is equal to 2, right? Hope you understood that. Next is question number 15. Again, you have a choice. The vector equation of the line which passes through these points is given by. Fine. So these are the direction ratios which are given to you. Let's write them in the factor form. And also the vector equation of the line which is passing through these 2 points, this will be given by, the vector for this one will be given by 3i plus 4j minus 7k. And for this line, it will be given by I minus j plus 6k. Now, according to the line, vector equation of the line which is passing through these 2 points is required equation of the line it will be 3i plus 4j minus 7k plus lambda I minus j plus 6k, right? Question number 15. Now, this is a choice question again. The vector equation of the line which is passing through these 2 points is given by what? Or the line of the shortest distance between 2 skew lines is dash to both the lines. Okay, is dash to both the lines. Fine. So here, let's say this is point A and this is point B. So direction ratios, A point is given by 3, 4, minus 7 and B is given by 1, minus 1 and 6. So direction ratios of AP is equal to, from here 3 minus 1 to 4 minus of minus 1. this is this is equal to 1 minus 3, which is equal to minus 2, minus 1, minus 4, that is equal to minus 5. 6 minus of minus 7, this is equal to 13. Now, equation of the required line, which is asked. Equation of the required line is given by r is equal to 3i plus 4j from here minus 7k plus lambda minus 2i minus 5j plus 13k. Fine. So this is answer to the question, right? What will I do is 3i plus 4j minus 7k. I'll take the minus outside. So this will be minus lambda 2i plus 5j minus 13k. So this is the answer to the first part of the question. Hope you understood that. Next is the line of the shortest distance between two skew lines is dash to the both lines. We are talking about the shortest distance. And you know one thing, the shortest distance is always the perpendicular dropped. So the answer is the line of the shortest distance between two skew lines is dash to both the lines. It is perpendicular to both the lines because shortest distance is only between any two ones. Shortest distance is the straight line, perpendicular line dropped. Hope you understood that. Next is question number 16. Now in this question, you are 16 to 20. They are very short answer type questions. Let's go with the first question for this section. That is question number 16. You have to find the value of sine inverse sine of minus 17 pi by 8. You know one thing, sine inverse x is equal to x, right? Where x lies between minus pi by 2 to pi by 2, right? Now, the given question is sine inverse sine of minus 17 pi by 8. So this is equal to sine inverse. I'll take the minus outside, minus sine 17 pi by 8. This can be written as a, okay. This can be written as sine inverse minus sine 2 pi plus pi by 8, right? You know, sine 2 pi plus something is equal to sine of that angle. Sine inverse minus sine 2 pi plus x is equal to sine x. So this gives you sine pi by 8, correct? Now this can further be written as, I'll take the minus sign inside, sine inverse sine minus pi by 8, right? That means this is simply equal to minus pi by 8. This is the answer to the question. Hope you got that. So this answer is equal to minus pi by 8. Right, let's move to the next question, number 17. For A is given by this matrix, what is the A inverse equal to? You're given A is equal to 3 minus 4, 1, minus 1. Determinant of A, this will be equal to 3 into minus 1 minus of minus 4 into 1, which is 1. Okay, let's talk about the adjoint of A. Now, adjoint of A will be given by minus 1, minus 1, 4, 3. Now, how did I get this adjoint? You need, this is a shortcut because in the papers, you don't have so much of time. I'll quickly discuss like how you can find the adjoint very easily for a 2 by 2 matrix. See, the adjoint of, please note it down, adjoint of a 2 by 2 matrix is transpose of its cofactor matrix. Okay, or I will tell you a very simple way to do this. See, the adjoint of any matrix A, if A is given by the A11, A12, A21, 22, so simply it will be done like this cross formula, right? How you can write it like, see, this one will change sign only, and this one will interchange their positions. Okay, so now it will be 2 will come here, A11 will come here. Here will be the only sign change. So minus A12 is, this is minus A21. Okay. According to that, you have the adjoint because A was equal to this. So 3 and minus 1, they interchange their positions over here. And 4 and 1, minus 4 and 1, they interchange their signs. Hope you understood like how I got the adjoint of A. There's a very easy way without wasting any time. And what you have to find out in the question is A inverse. You know, A inverse is equal to 1 upon determinant of A into adjoint of A. So A inverse is equal to 1 upon, what was the determinant? It was equal to 1, and adjoint of 1 was minus 1, 4, minus 1, and 3. So this is the answer to the question, minus 1, 4, minus 1, 3. Hope you understood that, right? Next is 18th question. If the function f is defined as fx is equal to this, when x is not equal to 3 and this is equal to k, when x is equal to 3 is continuous at x is equal to 3, then you have to find out the value of k. See, if the function is continuous at fx at x is equal to 3, you're given this function is continuous at x is equal to 3. Therefore, if it is continuous, then right hand limit of fx when x approaching 3 plus is equal to left hand limit of x approaching 3 minus fx is equal to f of 3. Okay. What is the right hand limit? Right hand limit will be given by limit x approaching 3 plus. You will have this function x square minus 1 minus 9 upon x minus 3 is equal to limit x approaching 3 minus x square minus 9 upon x minus 3 is equal to f of 3. This is equal to k from here. Okay. So now see, for this both the functions are same, so it's okay, I can pick up any one. Anyways, this will be equal to, over here, this can be written as limit, it will be 3 plus h, limit 3x approaching 3 plus, limit 3 plus h. Question number 18, if the function f is defined as fx is equal to this, when x is not equal to 3 and it is equal to k when x is equal to 3, this is continuous at x is equal to 3. Then you have to find out the value of k. You're given that the function is continuous at x is equal to 3. The function is continuous. That means the right hand limit of the function is equal to the left hand limit of the function is equal to f of 3. This is the right hand limit, left hand limit. This function, I'll simplify this function first. This is x square minus 9, which can be written as x square minus 3 square upon this. This will be equal to x plus 3 into x minus 3 upon x minus 3. So these two will cancel. You will have x plus 3 as the value of the function. Okay. So now this becomes limit h approaching 0, 3 plus h plus 3 is equal to limit h approaching 0, 3 minus h plus 3. This is equal to k because f of 3 is equal to k. It's given over here. Okay. So this becomes 6 is equal to 6 is equal to k. That is simple as that. The k's value comes out to be 6. That's it. Hope you understood that. The value of k is equal to 6 and this is the answer to the question. Let's move to the next question. Question number 19 says if fx is equal to x raised to power 4 minus 10, then you have to find the approximate value of f of 2.1. See, we have to find the approximate value. The function f x plus delta x, this can be written as fx plus f dash x into delta x. Here we have in the question fx is equal to x raised to power 4 minus 10. So f dash x will be equal to 4x cube. And you have to find out f of 2.1. So in this case, x is equal to 2 and delta x is equal to 0.1. Hope you understood this thing, right? Then f of 2 plus 0.1 is equal to f of 2 plus 4 into 2 cube into 0.1. right? So this gives me f of 2.1 is equal to 2 raised to power 4 minus 10 plus this is equal to 4 into 8 into 0.1, right? So f of 2.1 will be equal to this is 16, right? Minus 10 plus 3.2, which gives you the answer as 9.2. So this is the answer to the question. 9.2 is the approximate value of this function. Hope you understood that. Now, the second part of this question, actually, the second option of this question is in a choice. It says you have to find the slope of the tangent of the curve y is equal to 2 sine square 3x at x is equal to pi by 6. Let's go for that. So here's the B part. It's y is equal to 2 sine square 3x or dy by dx is equal to 2 into 2 sine of 3x into cos of 3x. See what I'm doing. Wait, I'll redo this thing. So it will be 2 into 2 sine 3x into the derivative of sine 3x. Hope you are clear this thing now. More clear, right? So this is equal to 4 sine 3x into what is the derivative of sine 3x? This is equal to cos 3x, and the derivative of 3x this. So this is equal to 4 sine 3x cos 3x into 3. That gives you 12 sine 3x cos 3x. Right? Hope you are clear till this. Okay. You have to find the value at x is equal to pi by 6. So this was your dy by dx. So dy by dx at x is equal to pi by 6 is given by 12 into sine 3 into pi by 6 into cos 3 into pi by 6, which is equal to 12 into sine pi by 2 into cos pi by 2. You know cos pi by 2 is equal to 0. Cos 90 is equal to 0. So this whole expression comes out to be 0 only. So dy by dx at x is equal to pi by 6 at x is equal to pi by 6 is equal to 0. Hope you got that. So this answer evaluates to be 0. Let's move to the next question, number 20. Here, you have to find the integral value for modulus of the function x minus 5 limits 1 to 4. Let's say this is equal to I. So limit 1 to 4 modulus x minus 5 dx. This integral can be written as 1 to 4. See, from 1 to 4, this function from 1 to 4, if I'm putting x is equal to 1, this should have a value of 0. So this will be written as minus of x minus 5 dx, because in the interval 1 to 4, this function will be negative. Okay, so this is equal to, I'll take the minus outside, integral of x 1 to 4 minus 5 dx, which is equal to minus, now this is x square upon 2 minus 5x limits 1 to 4 plus c. So let's put in the limits now. This is equal to minus 1 by 2 because I'm taking this outside now. Okay, minus 1 by 2, and this is for x only. This is 4 square minus 1 square plus 5 is taken outside, 4 minus 1 plus c. So this is equal to minus 1 by 2 into 15 plus 5 into 3 plus c. So this is 15 minus 15 by 2 plus c, or this is equal to 15 by 2 plus c. So this is the answer to the question, 15 by 2 upon c. Hope you got that. Next is question number 21. So now this question number 21 to 26, they are a bit lengthy questions because they are carrying 2 marks each. Okay. So the very first question for this one is the choice question again. If fx is equal to 4x plus 3 upon 6x minus 4, where x is not equal to 2 by 3, then you have to show that f of x is equal to x for all x not equal to 2 by 3. Also, you have to write the inverse of f function. You're given the function, let's say this is the a part, that fx is equal to 4x plus 3 divided by 6x minus 4. So f of x is equal to, this is given by 4 into 4x plus 3, 6x minus 4 plus 3 whole divided by 6 into 4x plus 3, 6x minus 4 plus minus 4. Okay, so let's open it up. You will have here, this will be given by 16x plus 12 plus 18x minus 12. Okay, whole will have the denominator as 6x minus 4. This is divided by, now again here you will have 24x plus 18 minus 24x plus 16 whole divided by 6x minus 4. Okay, during the division, these two denominators will get cancelled out. And what you'll be left with will be 16x, not 16 actually, I'll add them. So 16x plus 18x, this is equal to 34x upon, this will cancel out, and 18 plus 16, again, this will be 34. So this is equal to x. Okay, this is the value, this is equal to x. Fine. Now y was equal to 4x plus 3 upon 6x minus 4. Correct? So 6xy minus 4y is equal to 4x plus 3, or 6xy minus 4x is equal to 4y plus 3. Here x is equal to 4y plus 3 upon 6y minus 4. Therefore, fx is equal to 4x plus 3 upon 6x minus 4. All right. So this is the inverse of f. That's it. Hope you understood that question. Let's move to the B part, because we have already shown that this is equal to x over here. This was the hence proved. And you had to find out the inverse of the function f. And here, this is the inverse of the function f. All right. Okay. So hope you understood that. Let's move to the next question. Actually, the next part, check if the relation R in the set R of real numbers defined by R is equal to AB, where A is less than B, is symmetric or transitive. Let's solve that. So I'll erase the screen. Fine. This is the B part now. Now the given function is RAB, where such that A is less than B, right? For A, let A be the set of real numbers. Now for the first one, that is a symmetric, let A, B belong to A, and then AB belong to R, such that A is less than B. And this means if A is less than B, that means B is less than A. This is false. Therefore, B comma A does not belong to the set of R. That means R is not symmetric. Right? Now let's go for the second part, that is reflects. No, it was transitive. Okay. Now again, I'll say A, B, C. I'll take the three elements. They belong to the set A. Then if A, B, they belong to R, and B, C also belongs to R. A is less than B and B is less than C. That means A is less than C itself. And AC, though, they both belongs to R. Right? They both belong to R. Therefore, this relation is, of course, transitive. Hope you understood that, right? That means it is transitive. This option is the correct one. Let's move to the next question, number 22, integral problem. You have to find the integral of x upon x squared plus 3x plus 2. divided by, okay, let's say this is equal to I. You can write it as I is equal to integral of x upon, this can be split. You will have x squared plus 2x plus x plus 2 dx, or the two factors will be equal to, here will be x plus 2 and x plus 1 dx. Okay, now I'll be using the partial fractions. So x upon x plus 1 into x plus 2 is equal to a upon x plus 1 plus b upon x plus 2. Or cancelling the denominator and solving that, this will give you x is equal to a into x plus 2 plus b into x plus 1. Or this will give you a plus b. I'm concatenating and separating the x and the constant terms, plus 2a plus b, this is equal to x. Now let's compare the coefficient of x on both sides. Comparing coefficients of x on both sides. I'll get 1 is equal to a plus b. This is number 1. Also, if I compare the constants on both sides, comparing constants on both sides, you have 2a plus b is equal to 0. Let's say this is 2, right? Now solving 1 and 2 equations, you have solving 1 and 2, you will get, I'll solve it here. From here, I can say 2a is equal, from 2, okay? 2a is equal to minus b. If I fill in this equation, a plus b is equal to 1, or a plus 2a, minus 2a, sorry. A minus 2a is equal to 1. That gives you minus a is equal to 1, or a is equal to minus 1. So here you will get the value of a is equal to minus 1. If a is equal to minus 1, then b will be equal to 2. Okay. If b is equal to 2. So here the integral I becomes minus of dx upon x plus 1 plus 2 into dx upon x plus 2. So I will be equal to minus log of mod of x plus 1 plus 2 log of mod of x plus 2 plus c. Or this will be equal to minus log of x plus 1 plus log of x plus 2 square plus c. Or this will be equal to log of x plus 2 square upon x plus 1 plus c. This is the answer to the question, right? So hope you understood that. This is the answer. Let's move to the next question now. Question number 23, if x is equal to a cos theta, y is equal to b sin theta, you have to find the second derivative of y with respect to x. So in these cases, in such type of questions, I'll always find out dx by d theta first. So dx by d theta will be given by minus a sin theta if y is equal to b sin theta. Then dy by d theta will be given by b cos theta. Okay, now dy by dx will be equal to dy by d theta divided by dx upon d theta. And this is equal to b cos theta upon minus a sin theta, which is equal to minus b upon a cot theta. Okay, now you have to find the second derivative of y with respect to x. This is equal to minus b upon a, it will be kept outside, and the derivative of cot theta is equal to minus cosecant square theta into d theta upon dx, correct? So this will be equal to b upon a into cosecant square theta. What was d theta upon dx? From here, this is equal to minus 1 upon a into sin theta. Okay, so this becomes b upon a into, this will be Minus will be taken here into cosecant cube theta. So that's it. This is the answer, minus b upon a into cosecant cube theta. This is the answer to the first option of the question. Minus b upon a cosecant cube theta. Now the second part, you have to find a differential of sine inverse x with respect to e raised to power cos x. Let's go for that. I'll erase the screen. Okay, so you have to find the differential of sine square x. Let's say u is equal to sine square x, and du upon dx will be equal to 2 sine x into the derivative of sine x will be cos x. Okay, and you have to find the derivative with respect to e raised to power cos x. Let's say that is equal to v. So dv by dx can be written as e raised to power cos x into the derivative of cos x, which is equal to minus sine x. So this makes minus sine x into e raised to power cos x. Okay. Now you have to find out from here, you have to find out du by dv. So let's find out du by dv. This is equal to du upon dx upon dv upon dx. So this is 2 sine x cos x divided by minus sine x into e raised to power cos x. So these two things will cancel and you will have minus 2 cos x into e raised to power minus cos x as the answer. Hope you got that. So this is the answer to the B part. That is minus 2 cos x into e raised to power minus cos x. Right. Next is question number 24. You have to evaluate this given integral. Actually, this is pretty easy. Let's go. You have to, the limits are 1 to 2, 1 upon x minus 1 upon 2 x square dx. I forgot to write e into e raised to power 2x dx. Okay, so this is equal to integral 1 to 2, 1 upon x into e raised to power 2x dx minus 1 by 2 e raised to power 1 upon x square into e raised to power 2x dx. Now, I'll be using integration by parts over here. So this will be equal to first function into integral of second minus integral of derivative of first into this integral of second dx. The limits were from 1 to 2 minus integral of minus 1 by 2. I'm taking this inside now, minus 1 by 2. I'm not touching it actually because this will get cancelled ultimately. Okay, fine. So this is equal to 1 by 2, 1 by x into e raised to power 2x limits 1 to 2 plus integral 1 to 2 1 upon 2x square into e raised to power 2x into dx minus integral of 1 to 2 1 upon 2x square into e raised to power 2x into dx. So these two terms will cancel out and you will have 1 by 2 outside. 1 by 2 into e raised to power 4 minus 1 into e raised to power 2. This is equal to 1 by 4 into e raised to power 4 minus e square upon 2. That's the answer to the question. Hope you understood that. Let's move to the next question, number 25. You have to find out the value of this integral 0 to 1 limit x into 1 minus x raised to power n dx. Fine, I'll be using one concept over here, that is a limit 0 to a fx dx is equal to limit 0 to a f of a minus x dx. Okay, so this one will turn out to be 0 to 1 x raised to power n dx minus x raised to power n plus, wait. See, I'm doing some, wait. Here I'm changing, this will be 1 minus x and this will be 1 minus x whole raised to power n dx. Okay, so limit 0 to 1, 1 minus x into x raised to power n dx. This can be written as a limit of x raised to power n dx minus question number 25. You have to find out the value of the given integral. Limits 0 to 1 x into 1 minus x whole raised to power n dx. To solve this question, I'll be using one formula, because over here, if I'm having 0 to a limits fx dx, it can be written as limit 0 to a f of a minus x dx. Okay. So now this integral I becomes limits 0 to 1. This will be 1 minus x into x raised to power n dx, right? Let's write it more clearly. 1 minus x into 1 minus 1 minus x whole raised to power n dx. This is equal to limit 0 to 1, 1 minus x, because this 1 and 1 will cancel, into x raised to power n dx. Okay, let's open up the brackets. You will have 0 to 1 xn minus xn raised to power n plus 1 into dx. So this will be equal to, let's find out the integral, limit 0 to 1 xn into dx minus limit x raised to power n plus 1 into dx 0 to 1. This will be equal to, this integral will be equal to x raised to power n plus 1 divided by n plus 1 limit 0 to 1 minus x raised to power n plus 2 divided by n plus 2 limit 0 to 1. I'll take n plus 1 outside. So this will be 1 raised to power this minus 0 minus 1 upon n plus 2. 1 raised to power n plus 2 minus 0. This will be equal to 1 upon n plus 1 minus 1 upon n plus 2, which will be equal to n plus 1 into n plus 2, or n plus 2 minus n minus 1 in the numerator. So this will be 1 upon n plus 1 into n plus 2. This is the answer to the question. Hope you understood that. Let's move to the next question then. Question number 26. It says you are given two independent events A and B such that probability of A is 0.3 and B is 0.6. You have to find out the probability A naught intersection B naught. Okay, you are given PA is 0.3 and PB is 0.6. You are given A and B are independent events. Therefore, P A naught intersection P B naught, this is equal to the product of them separately. Okay. And what is P A naught? This will be given by 1 minus P of A. Right. Multiplied by 1 minus P of B. So this is equal to 1 minus 0 0.3 and this is 1 minus 0 0.6. That gives you 0.7 into 0.4, which is equal to 0.28, and this is the answer to the question. 0.28. Okay. Hope you got that. Next is question number 27. Now this is the C part, which is these are going to be the lengthy questions because they are going to carry your 4 marks. Okay. So you have to solve for x sine inverse 1 minus x minus 2 sine inverse x is equal to pi by 2. Fine. Question number 27. Now we are moving to section C. Question number 27 to 32. They are carrying 4 marks each. So they are going to be a bit typical sums. Let's start with that. You have to solve for it. Sine inverse 1 minus x minus 2 sine inverse x is equal to pi by 2. Here you have to find out the value of x. So I'll start. You are given sine inverse 1 minus x minus 2 sine inverse x is equal to pi by 2, or sine inverse 1 minus x is equal to pi by 2 plus 2 sine inverse x. Now I'll take the sine also towards the right hand side. So this will be 1 minus x is equal to sine of pi by 2 plus 2 sine inverse x. You know one identity, and that is sine pi by 2 plus x. This is equal to cos of x. Okay, because sine has changed into cos, and this will be cos of x. That this can be written as cos of 2 sine inverse x. This is equal to 1 minus x. Also, one more identity, 2 cos 2 theta is equal to 1 minus 2 sine square theta. So here this is behaving as 2 theta. So this will be equal to 1 minus 2 sine square. What was theta? Sine inverse of x. This will be equal to 1 minus 2 sine sine square, like this will cancel, and this will be x square only. Okay, this is equal to 1 minus x, 1 minus x, 1 and 1 will cancel, minus sign and minus sign will cancel. You have x is equal to 2x square, or 2x square minus x is equal to 0. Okay, and I'll take the x common, or here you have 2x minus 1 is equal to 0. Either x is equal to 0 or x is equal to 1 by 2. So if let's check the equation, given equation for both the values. The given equation was sine inverse 1 by x is equal to pi by 2. Okay, here was minus. Anyways, I'm writing it on the right hand side, plus 2 sine inverse x. So if I'm taking x is equal to 0, this will be equal to sine inverse 1 is equal to pi by 2 plus 2 sine inverse 0. And when x is equal to 1 by 2, this will be equal to sine inverse 1 by 2 is equal to pi by 2 plus 2 sine inverse. Here was minus, okay. No, sorry, not minus. No. All right. So here you have yeah, this is equal to 1 by 2. Correct. Sine inverse 1, this is at pi by 2 is equal to pi by 2 plus 0, which is absolutely true. So here sine inverse 1 by 2, pi by 6 should be equal to pi by 2 plus 2 into pi by 6. So in this case, pi by 6 should be equal to pi by 2 plus pi by 3, which is equal to 5 pi by 6. So that means they two are not equal. The LHS and RHS, they are not equal. This means x is equal to x is equal to 1 by 2 is not satisfying this equation, which surely means x is equal to 0 is the required solution for this question. Hope you understood that. Let's move to the next question. Question number 28, if y is equal to log x raised to power x plus x raised to power log x, then you have to find out the value of dy by dx. Okay, here y is equal to log x raised to the power x plus x raised to the power log x. I'm taking this one as u and this one as v. So this means y is equal to u plus v, or you can say dy by dx is equal to du by dx plus dv by dx. Now let's solve both of them separately. You have taken u is equal to log x raised to power x. Now taking again log on both sides, this you will have log u is equal to log of log x raised to the power x, right? So here you have log u is equal to x log of log x, correct? I hope you got till here. Okay. Now I'm going to take differentiating both sides with respect to x, both sides with respect to x. You have 1 by u into du upon dx is equal to x into 1 upon log x into the derivative of log x. Now this is the first function and the second function. Now this is the first function to derivative of second plus second function into the derivative of first. Hope you got that. That means du upon dx is equal to u. This is equal to x into 1 upon log x, and log x derivative is equal to this. So these two will cancel, and here you have log of log x. So du upon dx u I'm opening. This is log x raised to the power x brackets 1 upon log x plus log of log x. Okay. Now I'm going to our v. V was taken as x raised to power log x. Now again taking log on both sides. Both sides you have log of v is equal to log of x raised to power log of x. That means log v is equal to log x raised to multiplied by, see, this will come over here. Okay. So log x multiplied log x. Now differentiating both sides with respect to x. You have 1 upon v into dv upon dx. This is the first function into the derivative of the second plus the second function to derivative of first. So first function into 1 by x plus second function into the derivative of first. So this will give you 2 upon x log of x itself. And we will come on this side with a multiplication thing. So you have this as x raised to power log of x multiplied by 2 upon x log of x. This x and x will, sorry, no. This will not get cancelled like this because this is x is carrying some power, right? Okay, here was x. I hope you're clear here. So this is equal to, I'll leave it as such. Yeah, I'll write it properly once again. So this is 2 into 2 upon x into log x into x raised to power log x, right? That was your dv upon dx. Now I'm getting back to here. I'll put the values in this given equation to get my dy by dx. So here your dy by dx, which was equal to du upon dx plus dv upon dx. So here du was equal to log x raised to the power x 1 upon log x plus log of log x plus, and what was dv? This was x raised to power log x into 2 log x upon x. Hope you're clear till this. So here I'm taking log x raised to the power x common, and this is 1 upon um wait 1 upon log x, right? Plus that's it. I don't think anything further can be solved, so I'll leave it as such. Okay, plus log x raised to power log of x into 2 log x upon x. This can't be solved further. That's it. We can drop it here. This is the answer to the question. Hope you understood this. Let's move to the next question. Question number 29. Solve the differential equation x into sine y upon x dy by dx minus plus x minus y into sine y upon x is equal to 0. Given that x is equal to 1, when y is equal to pi by 2. Okay, you're given that when y is equal to pi by 2, x is equal to 1, and you have to solve this differential equation. In other words, you have to get the value of y. Okay, fine. So let's start with the sum. It's going to be lengthy one. Here we write the statement. We are given x into sine y upon x into dy upon dx plus x minus y into sine of y upon x is equal to 0. This gives you can write down sine of x into sine of y upon x into dy upon dx is equal to y sine y upon x minus x. Okay. So here dy by dx is equal to y sine y upon x minus x whole divided by x into sine of y upon x. Let's say y is equal to v into x. Let's say y is equal to v into x. So dy by dx will be equal to first function to derivative of second plus second function to derivative of first, right? So v plus x into dy upon dx is equal to, here dy by dx, I'm putting the value over here. This is equal to y, which was actually your vx. I'm directly writing into this y as v into x into sine of vx upon x minus x whole divided by x into sine of vx upon x. All right. So v plus x into dv upon dx is equal to, this x and x will cancel. Mm, and I'm taking common from here. So you have v into sine of v minus 1 upon x into sine of v. X and x will cancel. You have v plus x into dv upon dx is equal to v sine v minus 1 upon sine of v. I'm taking the v on the right hand side. X into dv upon dx is equal to v sine v minus 1 upon sine v minus v. That is equal to v sine v minus 1 minus v into sine v upon sine v. So these two will cancel. This is equal to x into dv by dx. That makes x into dv upon dx is equal to minus 1 upon sine of v, or sine v into dv is equal to minus dx upon x. Now you have to solve for y. Actually, we have to eliminate the d thing, the differentiate thing. That means what we have to do? We have to do the integration. So integrating on both the sides, you have integral of sine v into dv is equal to minus dx upon x. What is integral of sine? That is cos. So minus cos actually. So minus cos v minus cos v is equal to, this will be minus log x plus c. Right now, what was, we put y is equal to vx. That means v is equal to y upon x. So here cos y upon x is equal to minus log x plus c. Now you're given that at x is equal to 1, y comes out to be pi by 2. We have to get the value of c, that means. Okay. So that means this is minus cos pi by 2 upon 1 is equal to minus log of 1 plus c. Right? This is 0, this is 0. 0 is equal to 0 plus c, which simply means c is equal to 0. So let's get back what we had from here. Let's say this is equation 1. So 1 from 1, the equation becomes minus cos y upon x is equal to minus log x, or cos y upon x is equal to log of x, or cos y upon x minus log of x is equal to 0. This is the answer to the question. Okay, so that's it. We have solved and we got the answer as cos y by x minus log x is equal to 0. Hope you understood that. Let's move to the next question then. Question number 30. If a vector and a vector is given by this, b vector is given by this, represent two adjacent sides of the parallelogram. Find the unit vectors parallel to the diagonals of the parallelogram. Or, okay, that means we have a choice over here. Or using vectors, you have to find the area of the triangle ABC with the vertices this, this, and this. So actually, the second one is pretty easy. Let's solve both of them, and then you can decide whatever you want to do in your exam. So let's make the parallelogram. Here we have the parallelogram. So this is your vector A and this is your vector B. Okay. Let's say this is A and this is the B vector. Okay, wait. This is the B vector, A and B vector. And here is this A vector. Fine. So we have drawn the two vectors A and B. They represent the two adjacent sides of the parallelogram. Find a unit vector parallel to the diagonals of the parallelogram. So let's make the two diagonals. Here are the two diagonals. Okay. Yeah. So A is equal to I plus 2j plus 3k and B is 2I plus 4j minus 5k. Let D1 and D2, these be the two diagonals. D1 and D2 be the diagonal vectors. Therefore, what is D1 equal to? It is equal to A1. Sorry, not A1. This is A only plus B vector. And D2 is equal to, see, this is equal to, they are in the opposite direction. So this will be A minus B vector. Okay. So what is D1 given as? This is I plus 2j plus 3k plus 2I 4j minus 5k, which will give you 3I plus 6j minus 2k. And D2 vector will be equal to I 2j 3k minus 2I plus 4j minus 5k, which gives you, this is minus I minus 2j plus 8k. Now, unit vector parallel to D1 will be given by the D1 vector divided by the magnitude of D1 vector. Okay, so D1 vector was equal to 3I plus 6j minus 2k whole divided by the magnitude, which is given by 3 square, 6 square minus 2 square, which is 3I 6j minus 2k whole divided by 9 plus 36 plus 4, which is equal to root of 49. Okay, this one. So this is equal to 3I plus 6j minus 2k divided by 7, or this is 3 upon 7I, 6 upon 7j minus 2 upon 7k. Okay, this is a unit vector parallel to D1. Unit vector parallel to D2. Parallel to D2 will be given by D2 vector divided by the magnitude of D2 vector. And the D2 vector was minus I minus 2j plus 8k divided by the magnitude, which is minus 1 square minus 2 square and 8 square. This is 1 plus 4 and 64. That is equal to 69. So this is equal to minus I cap upon root of 69 minus 2 upon root of 69j plus 8 upon root of 69k vector. Okay, so these are the two unit vectors. This is like the second answer to the question, and this is the first answer to the question. You were asked these two answers. Hope you got that. So let's move to the B part of, not the B part, actually the second choice of the question. We have already solved the first one. Hope you understood that. Now let's move to the second choice for this question. So this is using vector. You have to find the area of the triangle with the vertices A, 1, 2, 3, B, 2, minus 1, 4, C, 4, 5, and minus 1. Right? That means AB side. So AB vector will be written as this is I cap, like 2 minus 1 minus 1 minus 2. This will be equal to minus 3 j, 4 minus 3, so plus k. This is AB vector, and AC vector will be equal to A and C. 4 minus 1, this is 3I, 5 minus 2 plus 3j minus 1 minus 3. This is equal to minus 4k. Okay. So we got the AB and AC vectors. Now we know that area of triangle ABC is equal to half into the cross product of AB and AC vectors. Okay. So that means this is, what is, first of all, let's find out AB and AC vectors. This is the cross product. So matrix form will be used I, J, K. This is 1 minus 3 and 1. Here is 3, 3 minus 4. So this will be equal to I 12 minus 3 minus J minus 4 minus 3 K 3 plus 9, which gives you 9I plus 7J plus 12K. And you have to find out the magnitude of this vector. This will be given by root of 9 square, 7 square, 12 square, which is 81 plus under the root 49 plus 144, which is equal to root of 274. Therefore, area of the triangle ABC is equal to half of root of 274 square units. This is the answer to the question. Hope you understood that. So this is equal to 1 by 2 root of 274. That's it. Let's move to the next question, number 31. A company manufactures two types of novelty souvenirs made of plywood. Souvenirs of type A requires 5 minutes each for cutting and 10 minutes for assembling. And of type B require 8 minutes for cutting and 8 minutes for assembling, given that the total time for cutting is 3 hours and 20 minutes. Okay. And for assembling is 4 hours. Profit for type A souvenir is rupees 100 each. And for type B, the profit is rupees 120 each. How many souvenirs of each type should the company manufacture in order to maximize the profit? You have to formulate the problem as an LPP and solve it graphically. So, first of all, let's say the company manufactures for type A. Here is for type A souvenirs. X, it's right at let the company manufacture question number 31. A company manufactures two types of novelty souvenirs made of plywood. Souvenirs of type A requires 5 minutes each for cutting and okay, type A, let's write it simultaneously. 5 minutes for cutting and 10 minutes assembling. And for type B, it requires 8 minutes for cutting and 8 for assembling. All right. Given that the total time for cutting is 3 hours 20 minutes for cutting, total time 3 hours 20 minutes, and for total time for assembling is 4 hours. Fine. The profit for type A souvenir is rupees 100 each. Here's the profit for type A, and for type B is rupees 120 each. How many souvenirs of each type should the company manufacture in order to maximize the profit? Formulate the problem as an LPP and solve the graph graphically. Solve it graphically. Okay, fine. So first of all, let's say the company, let the company manufacture X number, wait, manufacture X number of souvenirs of type A and Y number for type B. Okay, therefore, according for the LPP is here the linear programming problem is to maximize the profit which is given by P. Now it's giving 100 rupees for the type A and 100 rupees for type B. That was Y. Okay. So subject to here, what we have is 5x plus 8y. This is x and this is x and this is y and y. Subject to 5x plus 8y should be less than equal to 200 or and 10x plus 8y should be less than equal to 240. Because this is the, we are talking about the time. 3 hours and 20 minutes. This is equal to 3 into 60 plus 20, which is equal to 200 minutes. And 4 hours is equal to 240 minutes. So the time for cutting, total time for cutting for type A, that is 5x plus 8y should be less than 200, and for 10x plus 8y should be less than 240. Okay, these are the two inequalities where x and y, of course, they are greater than 0. Correct? Now, let's make the graph for this. So I have the two inequalities as this is, let's change them into equality. So 5x plus 8y is equal to 200 and 10x plus 8y is equal to 240. According to that, let's plot the graph. The 2 points. Here is for x and y. And this is for x and y. Okay. So for this one, if I'm putting x is equal to 0, when x is equal to 0, y is equal to 25, and when y is equal to 0, x will come out to be 40. Similarly, in this case, when x is equal to 0, we will have y as 30, and when y is 0, x will come out to be 24. Now let's plot these points on the graph. Here is the graph. Okay, so it's a bit like this. Fine. Let's make it, this is 10, 20, 30, 40. It's not the appropriate scale, I know that. This is 50 and 60. Similarly, in this one, this is 10, 20, 30, 40. All right. So now plotting the point 0, 25. So when this is 0, this is 25. This is the first point. And when y is equal to 0, y is equal to 40. So this is the second point. Let's join these 2 points. So this is the line. This is the line 5x plus 8y is equal to 200. The second line, when x is 0, y is equal to 30. So this is the first one. And when y is equal to 0, x is equal to 24. So this is the second point. So this is the, okay. So this one is the line 10x plus 8y is equal to 240. Okay. Now, this is the point of intersection of the two lines. When you will see the point of intersection, this is equal to 8, 20. Okay, when you will find out, you will actually plot it on the graph. So this point will come out to be 8, 20. Hope you understood that, right? So now for the, let's name the points. Let's say this is point A, point B, and this is point C. This is the required shaded region. Okay. So for the profit at the point A, what was the point A? This is point A is 0. 0, 25. All right. So this is equal to, from this, 100x plus 125, 100x plus 120y. So this will be 100 into 0 plus 120 into 25, which gives you 3,000 rupees. And the profit at the point B. This is what is the point B? This is 8 comma 20. So 100 into 8 plus 120 into 20, which is equal to 800 plus 20, 400 or 3200. Now for C, the point C is 0 comma 24. Sorry, 24 comma 0. So 100 into 24, 120 into 0, which is equal to 2400 rupees. So this is the maximum profit. Obviously, we wanted the maximum profit. So for the maximum profit, it will be for maximum profit, number of souvenirs of type A will be 8 and for the type B will be 20, right? Because this was the point 8 comma 20. Hope you understood that. This is the answer to the question. Let's move to the next question, number 32. 3 rotten apples are mixed with 7 fresh apples. Find the probability distribution of the number of rotten apples if 3 apples are drawn one by one with replacement. Find the mean of the number of rotten apples. Or there is the second choice for the question. I have read the first one. I'll continue with the first one till now. So here you are given 3 rotten apples are mixed with the 7 fresh apples. Fine. Let's write it. Let A be the event of taking out a rotten apple and B be the event of taking out a fresh apple. Okay. Then the probability of event A to happen is given. Find the probability distribution of the number of rotten apples if 3 apples are drawn one by one with replacement. So 3 rotten apples are mixed with 7 fresh apples. That means how many? 3 rotten apples. Probability of withdrawing rotten apples because there were 3 rotten apples and the total number of apples were 3 rotten and 7 fresh. This is equal to 3 by 10. Similarly, the probability of getting a fresh apple will be equal to 7 by 10. Hope you understood that. Now, let's say xi be the number of rotten apples taken out in 3 chances. You're given 3 chances. That means I can be like, no chance. 1, 2, or 3 rotten apples are taken out. There's a like no rotten apple, 1 rotten apple, 2 rotten apple, or 3 rotten apples. So that means the probability that no rotten apple is taken out is equal to probability that a fresh apple is taken out. 1, 2, and 3 because it was taken out 3 times. So this is equal to 7 by 10 into 7 by 10 into 7 by 10, which is equal to 343 upon 1,000. Probability that 1 rotten apple is taken out. That means this is equal to probability that a rotten apple is taken out multiplied by probability fresh apple multiplied by probability of fresh apple plus probability that a fresh apple is taken out multiplied the second one is a rotten apple multiplied by the third one is a, so this is the rotten, first one is rotten, this one is fresh, this is the probability of fresh. So this is the probability of fresh apple, this is the probability of rotten apple, this is the probability of fresh apple plus probability of withdrawing a fresh apple multiplied by probability of withdrawing a fresh apple multiplied by probability of withdrawing a rotten apple. So fresh, and rotten here. So this will be equal to 3 upon 10 into 7 upon 10 into 7 upon 10 plus 7 upon 10 into 3 upon 10 into 7 upon 10 plus 7 upon 10 into 7 upon 10 into 3 upon 10, which is equal to 3 into 3 upon 10 into 7 upon 10 into 7 upon 10, which will give you a total of 441 upon 1,000. Hope you understood this. Now, probability that you withdraw 2 rotten apples, this will be probability rotten multiply probability rotten multiply probability fresh plus probability rotten multiply probability fresh multiply probability rotten plus probability fresh multiply rotten multiply rotten. This is equal to 3 into 10 multiply 3 into 10, 7 into 10 plus this was 3 upon 10, 7 upon 10 and then 3 upon 10 plus 7 upon 10 into 3 upon 10 into 3 upon 10. So this will be again equal to 3 multiply 3 upon 10 into 3 upon 10 into 7 upon 10, which is equal to 189 upon 1000. Hope you're clear with this. Okay. So next, the probability of withdrawing all the three rotten apples. So probability A into A, which is 3 upon 10 into 3 upon 10 into 3 upon 10, which is 27 upon 1000. Right, now it's easy. Let's make the probability distribution table. So this is the table. Here you have xi 0, 1, 2, 3. So P of xi, this is 343 upon 1000, 441 upon 1000, 189 upon 1000, 27 upon 1000. Okay, what we had to find out in the question was you have to find the mean of the number of rotten apples. Okay, so the required question says you have to find out the mean which is given by submission from I is equal to 0 to 3 xi into pxi. So this is equal to 0 into 343 upon 1000 plus 1 into 441 upon 1000 plus 2 into 189 upon 1000 plus 3 into 27 upon 1000. Hope we are clear till here. So this will be equal to 0 plus 441 upon 1000, 378 upon 1000, 81 upon 1000, which will give you a total of 900 upon 1000, or this is equal to 0.9. Therefore, the mean of number of rotten apples is equal to 0.9, which makes 0.9 to be the answer of the question. Hope you understood that. So I hope you're clear. Let's move with the B part. B option. This is a choice question. So I'm going to erase the whole screen now. It says in a shop X, 30 tins of ghee of type A and 40 tins of ghee of type B. So here are the 30 tins of ghee of type A and 40 tins of ghee of type B, which look alike, are kept for sale. This is in the shop X, while in the shop Y, similar 50 tins of type A and 60 tins of type B are there. 1 tin of ghee is purchased from randomly selected shop and it is found to be of type B. Find the probability that it is purchased from the shop Y. Okay, so here I will say first of all H1 and H2 to be the events of purchasing tins of ghee from shop X and Y respectively. So the probability of purchasing from shop X is equal to probability of sorry, not here is H1, and from the shop Y, probability of purchasing the ghee from shop X is equal to probability of purchasing the ghee from shop Y, and this is of course equal to half because there are two shops. Okay, now let E be the event that ghee of type B is purchased. So probability that type B E event, like type B ghee is purchased from X shop is equal to 40 upon 70. Now how is that? It is 40 and this is total of 40 plus 30. this one. Okay, so this is 40 upon 70. Similarly, probability that type B ghee is purchased from Y shop, this is equal to 60 upon 60 plus 50, which is equal to 110. Okay, now I'm going to use the Bayes theorem to solve it. So by the Bayes theorem, required probability that the probability from the Y store type B ghee is purchased is given by probability E upon H2 into probability H2 whole divided by E upon H1 probability H1 E upon H2 into probability H2. Now let's fill in the values. This is 6 upon 11 into 1 by 2 whole divided by 4 upon 40 upon 70 into 1 by 2, 60 upon this into 1 by 2. So 1 by 2 will be cancelling, like I'll take it common. 1 by 2 into 6 upon 11. I'll take 1 by 2 common from here. This is 4 by 7 and this is 6 upon 11. This and this will cancel. So you will solve this. You will have 6 upon 11 whole divided by, this will come out to be 44 plus 42, which is equal to 6 upon 11 whole divided by 86 upon 77, which is 6 upon 11 multiply 77 upon 86. So this will give you 3 and 43. That's 21 upon 43. This is the answer to the question. Hope you got that. So the probability that it is purchased, type B ghee is purchased from shop Y is equal to 21 upon 43. Hope you got that. So let's move to the next question, number 33. Now we are moving to the section D, which are carrying 6 marks, which are pretty good ones. So that means expect some very good questions and lengthy ones and the typical ones now. Okay, 4 questions like the lengthy one, 6 marks question. You have to find the vector and the Cartesian equations of the line, which is perpendicular to the lines with these 2 equations and passes through 1, 1, 1. You also have to find the angle between them. Okay. All right. So the given 2 lines are this and this. I'm not rewriting these lines. I'm saying this is line A and let's say this is line B. So the direction ratios of line A is given by 1 to 4. And for the line B, the direction ratios are given by 2, 3, and 4. Let the direction ratios of the required line, which we have to find out, is ABC. Let the direction ratio of the required line is ABC. Now, because this line, the required line, is perpendicular to the given lines. Therefore, see, this is the direction ratios and this is the direction ratios. So A into 1 plus 2 into B plus 4 into C. This is equal to 0. Also for this, 2 into A plus 3 into B plus 4 into C is equal to 0. Let's say this is number 1 and number 2. Okay. Now let's solve A and B, 1 and 2 simultaneously by the cross multiplication method. Solving 1 and 2 by cross multiplication method. We can say A upon 2 into 4, 8 minus 3 into 4, 12 is equal to 2B minus 3B. This will be equal to minus B upon 1 into 4, 4, 2 into 4, 8 is equal to 4C minus 4C. This is equal to C simply. This will be 0. C over here. And this is equal to 3 minus 4. Let's say this is equal to some constant k. Therefore, what is A? This is equal to minus 4k, B is equal to k, 4k, and C is equal to minus k. Okay. So the direction ratios of the required line, we got ABC. Direction ratios of required line is given by minus 4, 4, and minus 1. Now the vector equation of line passing through XYZ and having direction ratios A, B, C is given as XI, YJ, ZK plus lambda of AI, BJ, CK is equal to 0. This gives you I plus J plus K plus lambda into minus 4I plus 4J plus, sorry, this is minus, okay, the C was equal to minus K, right? So this is equal to minus K is equal to 0. Why there is I, J, K? Because X, Y, Z, it is said in the question that it is passing through the point 1, 1, 1. So Xi plus Yj plus Zk is taken as I plus J plus K. Hope you got this thing. Okay. So this is the required line. That's it. We got our answer over here. And this is the first answer. Naturally, it is asking us two things. We have to find the vector and the Cartesian equation. We got the vector equation for the line. This is the vector equation for the line. Let's go for the Cartesian form also. So Cartesian form is given by x minus 1 upon minus 4 is equal to y minus 1 because it is passing through 1, 1 and 1 point. Y minus 1 upon this is ABC was equal to minus 4, 4 and minus 1. Okay, so upon 4 is equal to z minus 1 upon minus 1. This is the Cartesian form. Second answer. Third answer. Now we also have to find out the angle between the given lines. Okay, let's go for that. Angle between the lines will be given by cos theta. I'm writing the formula first. Cos theta is equal to A1, A2, B1, B2 plus C1, C2 whole divided by the magnitude, that is root of A1 square, B1 square plus C1 square multiplied by A2 square, B2 square plus C2 square. Here you have A1, B1 and C1 as 1, 2 and 4 and A2, B2, C2 as 2, 3, 4, right? Over here. So from here 1, 2, 4 and 2, 3, 4. That's it. Now the cos theta will be equal to 1 into 2, 2 into 3, 4 into 4 whole divided by 1 square, 2 square plus 4 square root of 2 square, 3 square and 4 square, which is equal to 2 plus 6 plus 16 whole divided by root of 1 plus 4 plus 16. This is 21. Root of 4 plus 9 plus 16, which is 29. Okay. So this is equal to 24 upon root of 609. This is cos theta. And what will be theta? It will be, of course, cos inverse of this value. That's it. So this is the angle between the two given lines and answer to our question. Part B. No, sorry, not part B. This is the third one. Okay. I hope you got that. Let's move to the next question, number 34. Now we have a choice in this question. Question number 34. Using integration, you have to find out the area of the region bounded by these two curves, or you have to evaluate the following integral as the limit of sums. So let's start the A part first. Using integration, you have to find the area bounded by these two curves. The two curves are x square plus y square is equal to 9. Here the center is minus g minus f. G was the half the coefficient of x. X term is missing. So the center in this case is the origin, that is 0, comma 0. Okay. And about the radius, this is equal to, this can be written as 3 squares. So the radius is equal to 3. Okay. The second one, x minus 3 square plus y square is equal to 9. So here the center will be given by 3, comma 0. And the radius, of course, is the same. It is equal to 3 units. Right? Fine. So now, let's say this is, no, name it as equation 1 and this one as equation 2. From the equations 1 and 2, what we get is, I have to find the point of intersection of these two curves. Okay. So x minus 3 whole square plus 9 is equal to, see from here, y square, if I say y square will be equal to 9 minus x square. And from here, y square will be equal to 9 minus x minus 3 square. Okay. Sorry, here is this. Wait, I have written something wrong. This is 9 minus x minus 3 square is equal to 9 minus x square. This gives me x minus 3 whole square is equal to x square. Okay. Or x square plus 9 minus 6x is equal to x square, which gives you, this will cancel. 9 is equal to 6x, or x is equal to 3 by 2. Now, when x is equal to 3 by 2, I'll pick up any equation. Let's say x square plus y square is equal to 9. When x is 3 by 2, that means x square is 9 by 4 plus y square is equal to 9, which makes y square is equal to 9 minus 9 by 4, which is equal to 9 into 3 by 4. This is y square. So here the y will come out to be 3 by 2 root 3. Plus minus. I hope you got this, right? Now, the 2 point of intersection of these circles, points of intersection of these two circles are 3, comma 2 and 3 root of 3 upon 2 and 3, comma 2 minus 3 root 3 upon 2. These are the 2 points of intersection. Now, based on that, let's plot graph so that we can understand it better. So this is the first one, the center with the origin. I'm not appropriate to the scale. So this is the center of it and the radius is equal to 3. Okay. This is the y and the x-axis. The second one, the center was this 3, comma 0 for the second circle. Here's the center for the first circle. And let's make a circle here. Okay. So this is what you need to find out in the question. The area bounded by these two circles. And these are the 2 points of intersection. This is 3 by 2, 3 root 3 upon 2. And this point is 3 upon 2 minus 3 root 3 upon 2. Okay. And this is x square plus y square is equal to 9. This circle is x minus 3 square plus y square is equal to 9. These are the 2 circles. I think I have written everything. Okay, this is also 3. Now you have to find out the required area. I'll use integration method. I think it's said in the question as well. Yes, we have to use the integration method. So required area will be equal to, I'm going to find out this area first. Okay. Not this area, sorry. I will find out this area. Okay. So this will be twice 0 to 3 by 2 y of second circle minus dx. Okay, plus from 3 by 2 to 3 y of first circle. dx. Okay. Hope you got this thing. Y of the second circle, y of the second circle, this one, right? From 0 to 3 by 2. And y of the second circle from 3 by 2 to 3. First circle from 3 by 2 to 3. Hope you got till here. Next, this will be, let's say this is equal to I, the total, or A, the area. This is equal to 2, limits from 0 to 3 by 2. What was the y of the second circle? The equation was y square is equal to, or y is equal to 9 minus x minus 3 square whole under the root. And for here, y was equal to root of 9 minus x square. Okay. This is equal to root of 9 minus x minus 3 square dx plus from 3 by 2 to 3 root of 9 minus x square into dx. So let's say this is, I'm solving them because if I'll solve them here, it will be very tough. So I'm giving them names such as, let it be I1 and I2. I will solve both of them separately. So here I1 is given to you as 0. Let's say this is equation 1. And 0 to 3 by 2 root of 3 square minus x minus 3 square dx, which is equal to, this is something the formula for a square minus x square. So this will be equal to x upon 2, which is x minus 3 in this case, upon 2, root of 3 square minus x minus 3 square plus 9 upon 2 sine inverse x minus 3 upon 3, the limits from 0 to 3 by 2. So this will be equal to 1 by 2 taken outside. This will be 3 by 2 minus 3 root of 3 square minus 3 by 2 minus 3 square plus 9 by 2 sine inverse 1 by 3, 3 by 2 minus 3. Okay. So that's equal to, okay, one more thing, not equal to, minus 0 minus 3 upon 2 root of 3 square, 0 minus 3 square, 9 by 2 sine inverse 0 minus 3 upon 3. So this is equal to 1 by 2. This will be minus 3 by 2 root of 9 minus 9 by 4 plus 9 by 2 sine inverse minus 1 by 2 minus 3 by 2. This minus 9 by 2 sine inverse of minus 1. This is equal to minus 3 by 4 into 3 root 3 by 2, 9 by 2 minus pi by 6 minus 9 by 2 minus pi by 2. This is minus 9 root 3 upon 8 minus 3 pi by 4 plus 9 pi by 4, which is 3 pi upon 2 minus 9 root 3 upon 8. I'll take the 1 by 2 outside. 3 pi minus 9 root 3 upon 4. So this is for, the integration for this one. Okay. The sum is not tough. Actually, the calculations only are the lengthy ones. Okay. Now I'm going to find I2. I2 is limit 3 by 2 to 3 root of 3 square minus x square dx. This will be equal to, now I'll be applying the same formula, a square minus x square under the root. This is x by 2 root of 9 minus x square plus 9 upon 2 sine inverse x upon 3, 3 upon 2 to 3. This is equal to 1 by 2, 0 plus 9 sine inverse 1 minus, yeah, let's say this is in the brackets. Okay, minus 3 by 2 root of 9 minus 9 by 4 plus 9 into sine inverse. This will be 3 by 2 upon 3. Okay, yeah. This bracket closed. So now let's solve it further. This will be equal to 1 by 2 sine inverse 1. This is pi by 2. So 9 pi upon 2 minus brackets 3 by 2. This will solving will give you root of 27 by 4 plus 9 sine inverse 1 by 2. This is 1 by 2, 9 pi by 2 minus this will be 9 root 3 upon 4. Okay. Minus 9 pi by, this will be pi by 6. Fine. This is equal to 1 by 2, 9 pi by 2 and minus 9 root 3 upon 4 minus 3 pi by 2, which is equal to 1 by 2, 6 pi by 2 minus 9 root 3 upon 4, which will be 1 by 2, 3 pi minus 9 root 3 upon 4. So this is the value for I2, integration second. Now, according to from 1, what we had was I is equal to twice of I1 plus I2, right? So now we just will fill in the values. I is equal to 2 into 1 by 2, 3 pi minus 9 root 3 by 4 plus 3 pi minus 9 root 3 upon 4, which is equal to 6 pi minus 18 root 3 upon 4. That gives you 6 pi minus 9 upon 2 into root 3. That's it. Square units. So this is the answer to the question. Such a lengthy question it was. It took a lot of time, but it was worth it. It was not a typical question. Only the calculations were very heavy in this question. Okay. It was a very simple question. You were given the two curves. You had to find out the center and the radius, and accordingly, then you find out the area, the points of the intersection of the curves. When you found out the point of intersection of the curve, then you have to find out this shaded region. Okay, so the shaded region will be like I am going to take the area covered by this curve. See this one, first of all. Area covered from 0 to 3 pi by 2 for the second curve, plus the area covered from 3 pi by 2 to 3 for the first curve. Then rest is the history. Just have to apply the formulas and solve your question. Hope you understood that, right? Now let's move to the next part, actually the part of this question, that is the B part. I'm going to erase the screen now. So evaluate the following integral as the limit of sums. So you are given, you have to find out limit 1 to 0, x square minus x dx. This is equal to limit h approaching 0, h into f of 1 plus f of 1 plus h, f of 1 plus 2h, f of 1 plus n minus 1 into h, where fx is equal to this, x square minus x, and nh is equal to 3. Okay, now let's get back. Integral 1 4x square minus x dx will be equal to limit h approaching 0, h into f of 1 will give you 1 minus 1 plus f of 1 plus h. This will give you 1 plus, see 1 plus h. This will be, first of all, I'm going to do the square. Fine. So this is equal to 1 plus h square plus 2h. Then minus h. X is equal to this. This will be minus h minus 1 plus. Now here is 1 plus 2h. So this will be actually 1 plus 2h square minus 1 plus 2h. I'm going to write the same form here. Okay. So 1 plus 4h square plus 4h minus 2h minus 1. So on till. So I'm moving to the last one. For this one, this will be 1 plus n minus 1 into h square minus 1 plus n minus 1 into h. Okay. So now this is 1 plus n minus 1 square into h square plus 2 into n minus 1 into h minus n minus 1 minus into h minus 1. Okay. Yeah. So that's it. So now this will be equal to limit h approaching 0, h is outside, this and this will cancel, right? And I'm going to take h square common. All right. Okay, fine. I'll take the h square common from here. This will be 1 square plus 2 square. Similarly, the next one will be 3 square. So on till n1 square, n minus 1 square. Okay. Plus h into, so see over here, over here, this will be 1 plus 2 plus 3, so on till n minus 1. See here, 2h minus h will give you h from here. 4h minus 2h will give you 2h from here. So this is 1, 2, 3, and so on for this one. And this 1 and 1 will always cancel. Right? I hope you're clear with this one. Now, this is limit h approaching 0, nh into nh minus h into 2nh minus h whole divided by 6 plus nh into nh minus h divided by 2. Now, from where did I get this one? You remember the two formulas? Sum of squares of first n natural numbers is given by n into n plus 1 into 2n plus 1 whole divided by 6. And similarly, the sum of first n natural numbers, it is given by n into n plus 1 upon 2. Sum of n natural numbers. Okay. Now this will be equal to, I'm going to fill in the values. NH was equal to 3. So 3 into 3 into 2 into 3 whole divided by 6 plus 3 into 3 upon 2. That's 9 plus 9 by 2, which is equal to 27 by 2. So this is the answer to the question. It was indeed a typical question because see, the question again was not tough, but the calculations were tough. So you have to pay very much attention to each and every step, because a single mistake at any step, like, it will give you a wrong answer for sure. Okay. So we are done with the question number 34. Let's move to the 35th question. You have to find the minimum value of ax plus by is where xy is equal to c square. We are given xy is equal to c square or y is equal to c square upon x. Let's say t is equal to ax plus by, or here tx will be equal to ax plus b into cx, b into c square upon x. I have used this equation in this case. Okay, let's find the differentiating both sides with respect to x. So dt by dx will be equal to a minus bc square upon x square. Now for the minimum value of t, minimum value of t, dt upon dx should be equal to 0, which means a minus b square bc square upon x square should be equal to 0. This gives you a x square minus bc square is equal to 0, or x should be equal to plus minus c root of b upon a. Okay. Now, let's find out the second derivative. So d square t upon dx square will be equal to 0 minus bc square into minus 2 upon x cube, which gives you 2bc square upon x cube. Now, See, I'm going to see the second derivative because we are talking in the question, we are talking about the minimum or the maximum value. Here we are talking about the minimum value. So let's put x is equal to c plus minus c root of b upon a over here. So the second derivative at x is equal to positive c root of b upon a. This is equal to 2bc square upon c cube into b upon a into this is cube, right? So this is root of v upon a. That gives you here this and this will cancel. This gives you 2. A will go in the numerator, and also this b and b will cancel. So this is 2a upon c root of a upon b. At the second d square upon dx square at x is equal to minus c root of b upon a. This will be equal to 2bc square upon minus c cube into b upon a root of b upon a. The same thing will happen. This and this will cancel. This and this will cancel. So this will be equal to minus 2a upon c root of a upon b. Therefore, the minimum value, see this is negative, and this is positive, right? Therefore, the minimum value of t occurs at x is equal to the positive one, because this is the positive answer, right? This is positive, so the minimum value will be occurring over here. This is c into root of b upon a. Therefore, the minimum value also, it occurs at this point, and what is the minimum value of t at this point? Minimum value of t at this point is given by a into x. Sorry, it was b upon a. C into root of b upon a plus b into x square, which is c square upon c into c upon this. Okay. So this will be equal to a c root of b upon a plus this c and this will cancel. bc root of a upon b. So this I'm going to take c common. A into root of b divided by root of a plus b into root of a divided by root of b. This will be c into root a into root b plus root a into root b. See over here, a upon what I'm using here is this can be written as root a into root a upon root a. So this will be equal to root a itself. So this is equal to 2c into root a b. Okay, I'll write it once again. 2c root a b. This is the answer to the question. Hope you understood that. Then let's move to the next question. So the answer to the question is 2c root of a b. Okay. Let's move to the next question, number 36. If A, B, C are pth, qth, and are terms respectively of a GP, then prove that this is equal to 0, or you have another question in the options. Fine, I'll go with the A part first. This is A and the B part. So here you are given A matrix to be okay, sorry, this is log, not A matrix. Wait. So you are given ABC are the pth and qth and the r terms respective of the GP, then prove that this is equal to 0. Fine. See, if ABC are in GP, then let's say A is equal to A, the first term, into R, the common ratio, divide raised to power P minus 1. Let's say B is equal to A, R, Q minus 1. And C is equal to A, R, R minus 1. Okay. Then The determinant is given by, wait. So here the determinant is log A R P minus 1 P 1 log A R Q minus 1 Q 1 A R minus 1 R1. Okay, now this log can be written as log A plus P minus 1 log R, log A plus Q minus 1 log R, log A plus R minus 1 log R. Here is P, Q, R and 1, 1, 1. Fine. So I'm going to split it up now. So this will be log A, log A, log A, PQR 1, 1, 1 plus P minus 1 log R, Q minus 1 log R minus 1 log R, P, Q, R 1, 1, 1. So I'm going to take log A common from here. This will be log A, determinant 1, 1, 1, P, Q, R 1, 1, 1 plus log R common from here. This will be P minus 1, Q minus 1, R minus 1. So P, Q, and R and 1, 1, 1. Correct? I hope you got till here. Yeah. So I think, okay, fine. See, over here, the C1 and C3 are same, are equal. So when the two columns or two rows are equal, then the determinant becomes 0. So this is equal to 0 plus log R. Now I'm going to split this one as well. This will be P, Q, R, P, Q, R, 1, 1, 1 minus 1, 1, 1, P, Q, R, 1, 1, 1. Sorry, here is a determinant sign. Sorry. Not this one. Here is got to be the determinant signs. So this is equal to 0 plus log R. Now again, the two columns C1 and C2 are equal. That means their determinant is equal to 0. The two columns C1 and C3 are equal. That means their determinant is also equal to 0. So this is equal to 0 plus 0 minus 0, which is nothing but equal to 0, and hence proved, because we had to prove this thing only in the question, right? Hope you understood that. We have proved the first part. Now let's move to the second part of the question, that if A is given to you as this matrix, you have to find out A inverse. Using A inverse, you have to solve these three equations. Fine, let's go. So here's the B part. You are given that A is equal to 2 minus 3, 5, 3, 2 minus 4, 1, 1, and minus 2. So you have to find out A inverse over here. First of all, let's find out a determinant of A. This is equal to 2 into minus 4 minus plus 4 plus 3 minus 6 plus 4 plus 5, 3 minus 2, which is equal to 0 plus minus 6 plus 5, that is equal to minus 1, which is not equal to 0. So that means matrix A is invertible. That means A inverse exists, because the determinant is not equal to 0. First thing we are clear with this. Now let's find out the cofactors for the, because we have to find out A inverse. So I'm going to find out the cofactors of matrix A. The cofactors are C1, 1. So first row, first column, if I'm leaving, that means I'm picking this one. right? Hope you got this. This is minus 2 plus 4. Minus 4, sorry, minus 4 plus 4, which is equal to 0. Now, first row, second column, if I'm leaving, first row, second column, if I'm leaving, so I'm having 3 minus 4, 1 minus 2, which gives you minus 6 plus 4, which is equal to minus 2. Yeah, and minus 1 sign, 1 plus 2 is also there. Okay, so this is equal to minus of minus 2, which is equal to 2. Right? Similarly, when you will solve for first row, third column, it will evaluate to be 1. Second row, first column on evaluation, it will give you minus 1. Second row, second column on evaluation will give you minus 9. Second row, third column will give you minus 5. Third row, first column, second column, and third column. This is 2, 23, and 30. I hope you know like how you find out the cofactors, right? Now, using that cofactors, the cofactor matrix will be 0, minus 1, 2, 2, minus 9, 23, 1, minus 5, and 30. So, adjoint of A becomes, it is 0, the transpose of this matrix, right? It is 0, 2, 1, minus 1, minus 9, minus 5, 2, 23, and 30. This is the adjoint of the matrix. All right. So what is the A inverse? This is equal to adjoint of A divided by the determinant of A. What was the determinant of A? It was equal to minus 1. And this is 0, minus 1, 2, 2, minus 9, 23, 1, minus 5, and 30. So this becomes 0, minus 2, minus 1, 1, 9, 5, minus 2, minus 23, minus 30, right? This is the A inverse. We got the first answer, right? You had to find out inverse. We got that. This is the first answer. So using A inverse, you have to find out the given three equation, or you have to solve these three equations. Let's go. See, it is actually 2x minus 3y. So this is already written in the matrix form. 3, 2, minus 4, this. 1, 1, minus 2, this third row. Okay. Right. So again, I'll be saying using the three equations. Let's write down 2x minus 3y plus 5z is equal to 11. 3x plus 2y minus 4z is equal to 5x plus y minus 2z is equal to minus 3. So here A matrix will be the same actually, which is given in the question, but according to this, 2 minus 3, 5, then 3, 2 minus 4, 1, 1 minus 2. This is the A matrix, and X will be given as X, Y, and Z. And the B matrix is equal to 11 minus 5 and 3. Sorry, it is 11 minus 5 and 3. You know, AX is equal to B. That means X is what? It is equal to A inverse into the B matrix. We already solved the same matrix inverse. This is X, Y, and Z. A inverse we already solved. It was 0, 1, minus 2, minus 2, minus 1, 9, 5, minus 23, minus 20, 13, multiplied by 11, minus 5, and minus 3. So let's solve that. First row, first column. So 0, minus 5, plus 6, minus 22, minus 45, plus 69, minus 11, minus 25, plus 39. This is XYZ. And that is 1, 2, and 3. So this gives you X is equal to 1, Y is equal to 2, and Z is equal to 3. So that's it. We got this answer as well. We had to find out A inverse. This we already found out. And using that same A inverse, X came out to be 1, Y came out to be 2, and Z came out to be 3. So students, that's all for this paper. We have completed the 36 questions. Many choices were this in this question. And see, it was like the last section D. Yes, it was tough. Very lengthy questions. So in my recommendation, do solve the section D first in the this paper, so that you don't waste your time on the one markers which are in the actually they are very easy also. So a very best of luck. Hope this video helps you to crack your exams, and don't forget to visit our website www.examsnet.com for a better practice and exposure to different question papers of different subjects. And do mind me, CBSE Class 12 Mathematics paper will be quite easy if you do visit our website and download our app. The link is available in the description box. You can also go through our website for the academics, for the entrance exam. PDF solutions are also available. Videos are also available. So do explore our website and download our app. That's all for this paper. Hope you understood it well. Keep shining, keep rising high. Bye. Champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great tool for you to practice for your class 12 CBSE examinations as well as your entrance exam question papers. So students, don't forget to download our app. The link is available in the description box. I'll be solving the set 2 of the Delhi 2022 paper class 12. The set 1 has already been explained in some another video. So except for the following questions, all the remaining questions have been asked in the previous sets. You can refer to our previous videos as well. So this is a matrix question. Let's go with this. Best of luck. Question number 1 for this set 2. If you have the two matrices x minus 1 and minus 1 0 minus 2 0 is equal to 0, then what is the value of x? So simply this is a multiplication, two matrices multiplication problem. Very easy one. I hope you know the rule. First row, first column. So it will be equal to x minus 2, right? Then here you have first row, second column. 0 plus 0. This is equal to 0. This means x minus 2 is equal to, this can be written as 0, comma 0, which means x minus 2 is equal to 0 or x is equal to 2. That makes option D to be the correct answer. Hope you understood that. Let's move to the next question then. Question number 2. This is an integral problem. You have to find out the integral of 4 raised to power x into 3 raised to power x dx. So you know one thing, when the bases are same, so when the powers are same, bases will be multiplied. This will give you 4 multiplied 3 raised to power x dx. This is 12 raised to power x dx. Now when you find out the integral of it, this will be equal to 12 raised to power x divided by log of 12 plus c. See what formula I'm using? A raised to power x dx is equal to a raised to power x divided by log of a plus c. So, sorry, according to this, you have option A as the correct answer. Hope you understood that. Let's move to the next question, number 3. A number is chosen randomly from 1 to 60. The probability that the chosen number is a multiple of 2 or 5 is. Fine, let A be the number which are multiple of 2 because it's an even number, and B be the number which are a multiple of 5. According to the question, you have to find out the probability that the chosen number is multiple of 2 or 5. So there I'll have the union that I want both of these event, any one of these event can take place. This is given by probability of event A to happen plus probability of event B to happen minus the probability of both the events to happen. So this is, see how many numbers from 1 to 60, they are a multiple of 2. There are 30 such numbers which are a multiple of 2. How did I get to that one? Let's solve first of all probability of A. This is 60 upon 2, right? Divided by the total number of numbers which were 60. So this is equal to 1 by 2. Now the probability that it's a multiple of 5. So how many multiple of 5 numbers are there in 60? This is 60 upon 5 upon 60, or this will be equal to 12 upon 60. I'll leave it here only. Okay, 30 upon 60, 12 upon 60. Also, A intersection B will be equal to, like it's a multiple of probability. It's a multiple of both 2 and 5. That means it's a multiple of 10. Hope you got that. So this is equal to the probability that both of them will occur. This is 60 upon 10 divided by 60, or this is equal to 6 upon 60, right? Now let's fill everything in the equation 1. Fill all these equations in 1. You have the PA union B is equal to PA plus PB minus PA intersection B. This is equal to 30 upon 60 plus 12 upon 60 minus 6 upon 60, which is equal to 36 upon 60, or this is equal to 3 upon 5. That's it. You got your answer as 3 upon 5. And we have option B as the correct answer. Hope you got that. Let's move to the next question. Question number 4, a relation R on a set A is called dash. If A1, A2 belongs to real numbers and A2, A3 belongs to the relation, relation R, implies that A1 and A3 also belong to the relation R for all A1, A2, A3 belonging to the set A. So in this case, what type of relationship is this called? This is called a transitive relation, because we are talking about A1, A2, and A3, 3 variables. So this is a transitive relation. Hope you got that. Next one is question number 5. You have to evaluate sine of pi by 3 minus sine inverse minus 1 by 2. Easy question actually. Sine pi by 3 minus sine inverse. This is let's write it. This is sine inverse pi by 3 minus, this can be written as minus pi by 6. So pi by 3 plus pi by 6, this is equal to sine of 9 pi by 6. Wait, it's not 9 pi by 6. 6, this is 2 pi plus pi. So this is equal to sine of 3 pi by 6, or this is equal to sine pi by 2, which is equal to 1. So this is the answer to the question 1. Hope you understood that. Let's move to the next question number 6. So you have a choice in this question. Using differential, you have to find out the approximate value of root of 36.6 up to 2 decimal places. Question number Question number 6, using differential, you have to find out the approximate value of root of 36.6 up to 2 decimal places. Or you have to find the slope of the curve of the tangent to the curve y is equal to 2 cos square 3x at x is equal to pi by 6. I'll start with the part A of this question, which is you have to find out the root of 36.6. See, this is a 36.6 is very much near to 36. So I'll use fx is equal to root x with x as 36 and delta x as 0.6. Now, note that f dash x over here, this will be equal to, see, I'm using fx is equal to root of x. Actually, I have written over here also, this is equal to 1 by 2 into root x. So that means root of 36.6 can be written as f of x plus delta x. This is equal to fx plus f dash delta x, f dash x into delta x. This is equal to root x, and this was equal to 1 upon 2 root x into delta x, this is 36 under the root plus 1 upon 2, 36 under the root, and delta x was equal to 0.6. This is 6 plus 1 upon 2 into 6 upon 6 into 10. So this will cancel. You will have 1 plus 6 plus 1 upon 20, which is equal to 6.05. So this is the approximate value for up to 2 decimal places for 36.6 under the root. Hope you understood that. So this is equal to 6.05. Let's move with the B part of the question now. You have to find the slope of the tangent to this curve. Y is equal to, let's say, you have to find out, you are given the curve y is equal to 2 cos square 3x. You have to find out the slope of the tangent to this curve. To find the slope of the tangent, you have to find the derivative of this y with respect to x. So this is equal to 2 into 2. The derivative of this will be, first of all, cos 3x into the derivative of cos 3x. So this is equal to 2 into cos 3x. This is the derivative is equal to minus 3 sine 3x, right? This gives you minus 12 sine 3x cos 3x. At x is equal to pi by 6, what do you have? Dy by dx at x is equal to pi by 6. This is minus 12 sine 3 into pi by 6 cos 3 into pi by 6, which is minus 12 sine pi by 2 cos pi by 2. You know, cos pi by 2 is equal to 0. Cos 90 is equal to 0. So this will evaluate to be 0, right? That means the slope of the tangent at x is equal to pi by 6 is equal to 0. Hope you have understood that. Let's move to the next question. Question number 7, you have to find out the integral of x plus 1 upon x into 1 minus 2x dx. I'll be solving this thing first, x plus 1 upon x into 1 minus 2x. I'll be using the partial fractions concept over here. This can be written as a upon x plus b upon 1 minus 2x. So that means x plus 1 can be written as a into 1 minus x plus b into x, which will be equal to a minus 2ax plus bx. This is equal to x plus 1, or x plus 1 is equal to, I'll take the, this will be b minus 2a into x plus a. So comparing the coefficients, you get a is equal to 1, which is the constant, and b minus 2a is equal to 1, which is the coefficient of x. So b minus 2 into 1 is equal to 1, which gives you b is equal to 3, which simply means that x into x plus 1 upon, not x into x plus 1, this was x plus 1 into x plus 1 upon x into 1 minus 2x can be written as 1 upon x plus 3 upon 1 minus 2x. Now, this is what you needed to find out. We have to do the integration on both the sides. This will be given by log of x plus 3 log of 1 minus 2x into the integral, this 1 minus 2x. This will be written as minus 1 upon 2 plus the constant c. So this is equal to log of x plus, this is actually minus 3 by 2 log of 1 minus 2x plus c. This is the answer to the question. Hope you understood that. Let's move to the next question, number 8. You have to find out the integral of x sine inverse x square upon root of 1 minus x raised to power 4 dx. Let's say this is equal to I, and I'll put t is equal to sine inverse x square. So dt will be equal to 1 upon root of 1 minus x raised to power 4 into 2x into dx. All right. So from this, now this integral will be I is equal to 1 by 2 t into dt. This will be equal to 1 by 2 t square by t plus c, or this is equal to t square by 4 plus the c. And what was t square? This was equal to sine inverse x square square upon 4 plus c. So I think that's it. This is the answer to the question. Yeah. Hope you understood that. Let's move to the next question. Tan of 2 tan inverse 1 by 2 minus cot inverse 3 is equal to 9 by 30. So here your LHS is equal to tan of 2 tangent inverse 1 by 2 minus cot inverse 3. Cot inverse 3. So this is equal to tangent of, uh, over here I'm using the formula of 2 tan inverse A. That is equal to tan inverse 2A upon 1 minus A square. Okay. So this will be equal to tangent inverse 2 into 1 by 2, 1 minus 1 by 2 square, which is equal to 1 by 4. And cot inverse 3, this is equal to actually tangent inverse of 1 by 3, because you know cot and tan, they are inverse of each other. So this is equal to tangent inverse of 1 by 3. Hope you got this. So now you have tangent of tangent inverse. This is 1 upon 3, 1 upon 3 by 4 minus tangent inverse of 1 by 3. This is tangent inverse of, sorry, tangent inverse of 4 upon 3 minus tangent inverse of 1 by 3. So this is something tangent inverse 1 A minus, I'm using the formula for tan inverse A minus tan inverse B over here, right? This formula is says tan of, this formula is equal to tangent inverse A minus B upon 1 plus A into B. So using that, this is equal to tangent inverse 4 minus 3 upon minus 1 upon 3 minus upon 1 minus 4 upon 3 into 1 upon 3. This is equal to tangent of tangent inverse 1 upon, this will be 1 minus 4 upon 9, right? Okay. Sorry, this is, wait, I have not written properly, wait. This is equal to tangent inverse of 1 upon 1 minus 4 upon 9, which is equal to 5 upon, sorry, here is plus, not minus. Okay, so this will be 13 upon 9, right? This gives you tan of tan inverse 9 upon 13, which gives you 9 upon 13 as your answer. And this is what we had to prove, right? Hence proved. Hope you got that. Let's move to the next question. Question number 10, you are given y is equal to cos x raised to the power x plus tangent inverse root of x. You have to find out dy by dx. Let's go. See, I will say this is equal to u and this is equal to v, and then dy by dx is equal to du upon dx plus dv upon dx. I'll solve u is equal to cos x raised to power x and v is equal to tangent inverse of root x. Taking log on both sides, you have log u is equal to log of cos x raised to power x, which will give you x log of cos x. This is equal to log of u. And again, taking no need to take log over here in the second case. No, this is tangent. Okay, fine. So here simply dv by dx will be equal to 1 upon root of x square. This is equal to into 1 upon 2 root x, because the derivative of under root x will be 1 upon 2 under root x. So this is equal to 1 upon 2 root x into 1 plus x. This is dv by dx. Now here, coming back to this one, you have here 1 by u du upon dx is equal to first function into the derivative of second. Cos x derivative is equal to minus sin x and plus second function into derivative of first. Correct? So du upon dx is equal to u. I'm taking on this side. So this is equal to minus x into tangent x plus log of cos of x. What was u equal to? I will fill u. This is equal to cos x raised to power x. Cos x raised to power x minus x tangent of x plus log of cos of x. Now let's fill this and this in this equation, in equation 1. From equation 1, we already have dy by dx is equal to du upon dx plus dv upon dx. What was that du? It was cos x raised to power x minus x tangent x plus log of cos x plus 1 by 2 root x, x plus 1. So this is the answer to the question. Hope you understood that. Let's move to the last question of this set, that is question number 11. So find the point on the curve y square is equal to 4x, which is nearest to this point 2 comma 1. Question number 11, you have to find the point on the curve y square is equal to 4x, which is nearest to the point 2 comma 1. So this is the curve. Let's make y square is equal to 4x. This is a parabola. This is this parabola. This is y square is equal to 4x. Let this be the point. Let this be the point a, x, y, which is nearest to the point. See, this is 2 comma 0, which is nearest to this point 2 comma 1. So where is the point 2 comma 1 according to here? 1 will be here. So let axy be the point which is nearest to this point 2 comma 1. Let axy be the required point. Okay, then the distance between the two, d, is given by root of 2. See, this is the point 2 comma 1. This is the point x comma y. So 2 minus x square plus 1 minus y square. You had the curve as y square is equal to 4x or x is equal to y square upon 4. So this d in terms of y can be written as 2 minus y upon y square upon 4 plus 1 minus y square. Square and square as well. Okay. So now squaring both sides. Squaring both sides, you get d square of y is equal to 2 minus y square upon 4 square plus 1 minus y whole square. So let's say this is equal to z. Z is the maximum value for minimum value for this. So z is equal to 2 minus y square upon 4 square plus 1 minus y whole square. Let's find out the derivative of this with respect to y. This will be equal to 2 into 2 minus y square upon 4 into the derivative of minus y square upon 4. This will be minus 2y upon 4 plus 2 into 1 minus y into derivative of minus y, which is equal to minus 1. So dz upon dy is equal to minus y, 2y. See, this 2 and this 2 and this 4 will get cancelled. So minus y into 2 minus y square upon 4 minus 2 into 1 minus y. Hope you are clear till this. So dz upon dy is equal to minus 2y plus y cube upon 4 minus 2 plus 2y, or dz upon dy is equal to y cube upon 4 minus 2. Right? Now, for the minimum and the maximum value, this has to be 0. dz upon dy for minimum or maximum value, dz upon dy should be equal to 0, which means y cube upon 4 minus 2 should be equal to 0, or y cube should be equal to 2 into 4, which is 8, which gives you the value of y is equal to 2. And what we needed to find out in the question, you have to find out the point on the curve which is nearest. So when y is equal to 2, what will be the value of x? Wait. Wait. See, when y is equal to 2, I have to check for the second derivative of this. Like, is it minimum or maximum? Okay. First of all, we have to do this. Then only we can check whether the point is having the minimum or the maximum distance. So d square z upon dy square, this will be equal to 3 square y upon 4. Or the second derivative at the point y is equal to 2 will be given by 3 into 2 square upon 4, which is equal to 3. And 3 is greater than 0. That means z is having minimum value because this is positive. Therefore, z is having minimum value at y is equal to 2. Right? So we got our point. For that point, y is equal to 2. And we had the curve as y square is equal to 4x, which means 2 square is equal to 4x, or x is equal to 1. So the required point is 1, 2. This is the answer to the question. Hope you got that. Let's move to the next question. So here is the required point. It is 1, 2. This is the answer to the question. Hope you understood that. Let's move to the next question. So students, with this, we have completed all the 11 questions for the set 2 of DARI 2020 paper. Hope you understood them well, and do visit our website www.examsnet.com to practice for similar type of multiple entrance exam question papers for the CBSE class 12, as well as other entrance exam question papers as well. You must download our app. The link is available in the description box. So students, keep shining, keep rising high. A very best of luck for your exams. That's all for this paper. Bye.